Let's do the tech survey one first. Cool. And
Can I close the Discord so when I'm there something?
okay.
Do I have Discord?
I think we're live.
We're live.
Yeah, this works. Okay. I'll look at my notes real quick.
Oops. Trade spot.
Okay. Where's my phone? There we go. That's what I need. Okay. Okay, thank you for making it, everyone, tonight. My name is Levi Zinning. I'm the president of Springfield Devs. Before we get started, there's a few announcements, some upcoming stuff that we want to go over real quick. Number one is we have released our yearly tech survey. So this webpage right here, sgf.dev 2022 tech survey. We'll throw a link to this in Discord if there isn't.
There's already one to this.
There is already one to this one, yep. So it's a survey kind of going over, I believe, like your interests in tech and what you use and what kind of presentations you want to watch and stuff like that. So please go fill this out. This will help in a lot of ways. Pull up the Discord. The other thing that we wanted to go over really quick is a reminder about our holiday party, which is going to be next month, the first Wednesday of December. I believe it's is it the 6th or the 7th? 7th? December 7th. It'll be here at the E-Factory up in the Idea Loft. And we are doing there we go, yeah. We're doing a casino night, right?
Yes.
There's gonna be lots of food there, games, ugly sweater asterisk contest. Anything else I'm missing?
Just, spouses, friends, colleagues, everyone's welcome. We want to have a good party, want to rub shoulders with other people in the devs community, maybe people that aren't part of the group that maybe would be interested in joining. So come on out and invite your friends if you think they would enjoy it as well.
Cool.
The actual this is a like a pre-announcement. The actual details of this are going to come out tomorrow. And the important thing is there is an RSVP link. We need to get RSVPs somewhat before the event so we can make sure we have the right amount of food and make sure we have enough gaming tables for everybody to enjoy the event. I don't know if I was on camera
Nope,
or not.
that's great. Another kind of announcement thing is, I don't know if anyone here has heard of Anthos before, but they are a sponsor of the group. They're a VC firm that is looking to get feedback from a group like ours on potential companies that they're looking to invest in. They've been kind of in our announcements the past few months. Kind of the biggest thing to talk about right now is they're specifically looking on getting some feedback around a particular tool right now called repl.it, which is, or Replit, can't remember exactly how they pronounce it, but it's essentially like an online IDE that's pretty dang cool. If you're interested in trying out this tool and giving some of your thoughts around it, this group is definitely interested in hearing from you. There is a message in our Discord in the general channel from Mike Bates with details about what to do if you're interested in kind of being a part of this group to give feedback. Also, if you have any questions about that, feel free to find me afterwards, and I'm happy to dive more into it. The last thing is we are looking for volunteers to join our events committee. So if you are interested in helping plan these events, helping coordinate some of the logistics around the food and finding presenters and all those kinds of things, come talk to me or Ben Pomeraki, who's our head of the events committee right now. We're glad to have you come and volunteer and help keep these events going. Anyone got any other community announcements or anything like that we want to touch base on? Okay. With that, the presentation setup for tonight is Ryan is going to be doing his presentation about observability and monitoring here in this room. And then Mike Bates was going to be giving a presentation on Practical Blazor, which is Microsoft's framework for building web applications. He couldn't be here tonight, so he has pre-recorded his talk, and it is in is it the BKD room or?
Forbes.
Forbes room, that's right, they changed the name. It is in that other room there. Ben, I believe, right after this is gonna go over there and start this pre-recorded video. It'll also be available on YouTube forever, so if you wanna find that link later, you certainly can as well if you're trying to decide which one to go to. Without further ado, though, I will hand it off to Ryan here, and then we'll go get
Anybody
the
that wants to
videos.
go to .NET, we'll go this way. Good luck, Ryan. I'm
Thank
sad
you.
to miss.
Ryan. All right.
Is anybody going to watch that?
I have a clicker. It's okay, but
Is that okay?
that's fine.
Grab some pizza.
Whew. You got this,
Please
dude.
eat all the pizza. I ordered way too much.
That's all right. All right. Well, thank you everybody for coming. This presentation is going to be covering application and system monitoring in the modern age, and some tools and open source software we can do to achieve this. Real quick, I'm Ryan. I am a systems reliability engineer at Cloudflare, which means I'm a janitor of making sure that things stay online and working well. Before that, I was a software engineer for 2.5 years at Jack Henry, where I learned a lot of those tools I'm about to present on. Been writing code for like 10 years and happy to show kind of what I've learned. So the agenda for this talk is we're going to talk about monitoring. What does it mean? How is it different than observability? What can we do with monitoring? Things like that. We're going to talk specifically a lot about Prometheus. Prometheus is one of the largest open source monitoring platforms out there. Hundreds and hundreds of companies use it. We're going to talk about how it's implemented, how it's used, and what we can do with it, and all kinds of cool things we can do with our metrics. So first and foremost, why should I care about this? I'm not an SRE, I'm a software engineer or whatever. I would answer that with this. If you don't have monitoring or observability tools for your code, you're going to make the news. Downtime is no longer an option. We have to write systems that we understand what's going on and can solve them almost immediately. So on top of that, it's really important to mention that with monitoring, it's not just about being able to debug things when things go wrong. It's about being able to see where things might be getting rough, like where you have a Docker container that's using a little bit too much memory, too much CPU, things of that nature. It's really good to have tooling to know and maybe alert that they're happening in advance. And on top of that, it's kind of a responsibility thing. Like if I write code and I deploy it to production, I want to be able to make sure that I can personally debug it, or if somebody comes after me, they can also debug it and solve issues as well. So I kind of had to steal at least a technical definition of what monitoring is. Generally considered to be some type of like tooling or technical solution to understand the state of what it is that we've deployed into production, whether that be Kubernetes or Nginx or some microservice or just some simple backend. We're going to need to have some way of figuring out what's happening in our system. So general philosophy of monitoring is that we collect numerical data called metrics. We ingest this somehow. We generally like to see metrics over time, so we plot useful information over a period of time that we can use to kind of derive interesting information about what's happening. Generally, monitoring is something proactively. We will set up metrics of things that could potentially go wrong or could give us an indication things could be going wrong. So for example, like if I'm using 90% of my CPU on my microservice that I'm writing, then I know something could be going like incredibly wrong, and I'd want to know about that. So examples like metrics that any engineer at any layer of the stack might want to know about is like how much CPU is my server using, how much CPU is my container using, how much RAM is my microservice using, things of that nature. The amount of requests per second I'm doing, that's really important information to know. Because let's say for whatever reason your application, it's Christmas Day and people all of a sudden are just flooding your application. You want to see like which microservices are being used more, or how can I scale up, things of that nature. And just general information about what kind of requests are happening, how long these requests are taking. Just any type of useful information for debugging is extremely powerful. I should state this, so monitoring and observability are not truly the same thing. You'll hear this defined different ways depending on which company is trying to sell you something or which book you're reading. Some people consider it the same, some people don't. We're covering just monitoring. Observability is sort of this like philosophy of reactivity of building systems to where you can answer questions that you haven't really thought of. Monitoring is the opposite of that, where we like know of things that could potentially go wrong, and we're going to define metrics to watch these way in advance. They're not separate ideas, they're not different methodologies, they're complementary. If you have good observability and good monitoring, they help each other out, and so that you can build systems that are fundamentally just more reliable. So moving on, the main point of this talk is to introduce Prometheus. Prometheus is a super, super lightweight open source monitoring tool. I was looking on GitHub, it's like, I think in the top 200 most starred repos of all time. It's used by hundreds of companies. It's sponsored by the CNCF, which is the organization that's like responsible for the steering of like Kubernetes and containers on the edge and all of these other wonderful things. The best part about Prometheus is that it is really, really simple to set up. It's really simple to build our applications to use Prometheus. And then it also supports really useful things of like visualization, like understanding graphs and things of what our metrics are. We can also build like programmatic alerts to say, oh, like my application is, running, all of its requests are taking 500 milliseconds when before they were taking like 30 milliseconds. That would be something you might want to alert somebody on. And then most importantly, and this is what makes Prometheus so powerful, is that Prometheus is completely agnostic to the language, the technology. It's implemented for everything. If there is a language or a technology that doesn't have something that implements Prometheus, I will pay you money, because I bet you it does. So moving on. So Prometheus is, the way that Prometheus works is that it pulls in metrics and does something programmatically with them. It does this by just using simple HTTP along like an endpoint / metrics. And then it will pull in this data, it will save this data for future use, and then you can do interesting things with your metrics stored in Prometheus. So as I said earlier, that like Prometheus really can scrape any technology out there. As long as you have an IP and a port, as long as that is exporting a valid Prometheus config, I guess, we'll just call it a config for now, it's scrapable, it's ingestible, and you can do really interesting things with it. So just to kind of get like a broad idea of like how Prometheus works is you have your Prometheus surface that will, I guess this is your left, will pull in services that you've written, or servers or nodes or containers or clusters, whatever you want. It will pull in that data. It can fire alerts on that data. So if like, your cluster goes down, you can send alerts to like your ops team. You can query data, so you can make really pretty visualizations or useful monitoring graphs to like kind of keep track of how the state of your systems are. That's effectively it. And you can do this for effectively the price of free. So like I said, Prometheus is all about numerical data. I just want to quickly go over, there's 4 types of Prometheus metrics. We're going to cover 3. There's a counter, which is like the concept of like, I have a metric or a number that can only go up. So an example of this would be like the amount of logins on my website, right? Logins, you're never going to have someone not log in, like, or I guess they could log out, but that, we want to cover total logins. You can have a gauge. A gauge is the idea of like kind of on a car, your car can go up to like 60 miles per hour and then back down. So like in code, this could be useful to think about like how many requests per second am I doing? I could be doing 200 requests per second on my service like now, or later it can be 0. And then there's another type, this one's a bit more complex, and we'll dive into this one, is a histogram. A histogram is the idea of buckets, and we're sorting different numerical data into those buckets. So like in this example here, this is a latency heat map, which can tell us that recently, since this is a time series database, most of our requests have been in the under 100 milliseconds bucket, right? And then above that, all of my requests are under 500 milliseconds, right? And this can give us an idea of like kind of the state of our application, where is it spending time? And so, that's kind of the idea behind a histogram. The way that all of this is done is through something called PromQL. It's a query language specifically for Prometheus. Kind of a pain to learn. I'm not gonna get into like the super nitty gritty because I'd be like trying to teach you guys SQL. That's not fun. But we'll see some examples of it, and it's pretty useful that way. So this is an example here of like the amount of total requests that my application might have been doing. And it doesn't matter, and it's saying the environment can be staging, testing, development, and it's not a GET request. So we can write programmatic queries to like pull out data, and if we're interested in that kind of thing. So moving on, like I want to really get into the examples because just to show like this is all abstract ideas right now. The format of a metric is very, very simple. This is the format that Prometheus exports. It's in plain text. There's no massive protocol or weird implementation. It's just straight up text. And so a metric has like a help, like what is this metric for debugging reasons. There is the name of the metric next to the type, and then the type it is. So a gauge means it can go up and down. And then this is an example of like a Node.js application and how much memory is allocated on the heap. So you can see like this number is like a large number. It's however many bytes it is, and that number can fluctuate as your application runs. Here's an example of like a histogram. So like when my web browser like went to grab the favicon path, this looks like super complex and super nasty, and we'll abstract all of this away. But the idea is that you can fill buckets to understand where how much time each request took. So basically what this means is that whenever my web browser went and tried to grab the favicon, all of the buckets filled because it only took like less than a millisecond to do. We'll see a better example of that in a minute. So getting into some actual coding here, this is my example for a simple microservice, right? The most simple backend I could possibly think of. So we have this route here for /home, and it just says hello world, right? Super advanced stuff here. But the goal here is that we're going to instrument this service with Prometheus, so that way we have an idea of like what's happening in this application as it runs. So I think a useful thing is like, okay, how many visits to the homepage have we seen? We can tell Prometheus to set up some code to add a metric for the amount of visits at our /home route, and then all we have to do is the second line here is we just say every time we see this we increase the counter, right? And then so as this gets ingested by Prometheus, we'll be able to see over time how many people have logged in, and we can see the graph change as people are logging in. And then we need to register metrics. And then we need to actually set up the /metrics endpoint, kind of like I was saying earlier, is that this is all done over HTTP. And that will spit out all of the required Prometheus format. And I will say, if this was bad Node.js, I don't write Node.js, I just did this as an example just to prove that Prometheus really does exist in everything. Like, I just chose it kind of by random. So getting into kind of an actual example here. So our application here, so this was our /home that we saw earlier. We have just our hello world. And I'm running this service on localhost 3000. And I go to /home. We get hello world. Nothing too exciting. I'm just kind of refreshing the page, because if we go to the /metrics endpoint, you'll see we have a ton of data, a ton of metrics here, right? And this is like super confusing, and we'll cover that, but you can see that while I was refreshing there, our counter went up. Our total visits went up to 30. If I come back over here, refresh one more, I come back, it's 31, right? And so Prometheus will pull this data somewhat regularly so that it can generate graphs and useful information about this, right? And this one's not particularly interesting, but that's just like the simple example. But you're probably asking yourself, like, okay, this is like a ton of data. Like, what is all of this? Like, this is junk, right? And the answer is not really. So one of the most powerful things about Prometheus is that almost everybody who's implemented Prometheus in the past, like these people who implemented Prometheus for Node, they actually went ahead and exported a ton of information about the runtime of Node itself, right? Like how much memory am I using? How much CPU am I using? Things like the event loop, because I don't know how the event loop works in Node, but all of this information they gave to us for free, and the only thing we had to do was just import Prometheus into our application, right? So if we're like trying to understand what our system is doing, we now have a general idea of how these things are solved, or how these things are looking over time. And this is kind of ugly. This doesn't really like tell us a lot yet because it's just this nasty format that doesn't really mean anything. But we'll kind of show like how this can be useful here in a minute. But this is something I really wanted to show, is that we added maybe like 5 lines of code, and we now have much better idea of what our system is doing. So moving forward, Prometheus has its own web UI, which I'm just happening to run as like a Docker container right now. So Prometheus is scraping in. I'm actually getting a little ahead of myself here. So we have all of our metrics, right? And it's pulling in our metrics on the /metrics endpoint. We can configure Prometheus to pull in these metrics, right? And so I kind of had to like get around this because like Mac OS was kind of weird, but our service was running on port 3000, and we are pulling in those metrics now through Prometheus on port 3000, right, with that /metrics endpoint. And just to like kind of prove that we're actually doing something with this, this is what do we have? Our total visits. So if we want to see our total visits graphed, we can just pop in this metric, and we can see that over time our number increased, right? So see, this is when I refreshed it once, right? And we now have an idea of like how many visits we're having as a graph, which is like particularly useful, I would say. You can also do like significantly more complex queries. Like there's this query that we can do to like look at how much time our requests are taking. Oh wait, I know why that is. Sorry. Moving forward. I'm really confused on why that didn't work, but we're going to move on. But the idea is that we have all of these metrics now. What do we do with them, right? These don't really tell us much. They give us some numbers about maybe what our application is doing, whatever. So we have metrics. What are we going to do with them? We're going to analyze them, right? We're going to try to figure out something useful from them, whether we're debugging, trying to solve an issue, something of that nature. So the way that we would do this is this application called Grafana. You've probably seen Grafana used in TV shows, movies. It's the most ubiquitous graphing library, or not library, but framework or visualization tool out there. Extremely popular for Prometheus. They're kind of one and the same. Some people sometimes will refer to them as each other, but they are very different. But Grafana will allow you to build graphs and dashboards for any type of service, any type of tool, as long as Prometheus is exporting metrics about it. So just to like kind of give an idea of what this looks like. So I could show like getting into the like really nitty gritty of building dashboards and like understanding what all of these things do, but that's like very tedious and very long. So I kind of created an example here before. But like, for example, this is an example of what our microservice is like actively doing, right? We can see earlier, just a minute ago, when I was refreshing the home page, when I was doing it a lot, that I was doing somewhere around 10 requests per minute. We can see that how much time it took roughly for every request to finish, right, on the 95th. So what that means is 95% of our requests were taking this amount of time to complete. And then we can also see like our memory usage, right? And all of these things are Prometheus metrics. So I can go, right, and I can look on the metrics endpoint, and I can see that this was what the number was then. And if I refresh again, it's like changing constantly. It's fluctuating, right? And this is the amount of memory that Node.js is using. And so by telling Grafana, I like to know what the average is of the amount of memory our service is using. And this is all PromQL, by the way, which is, kind of like its own version of SQL for Prometheus. We can see what our memory usage looks like over time. And so, that's pretty powerful, because if we're ever debugging, like trying to figure out what is going on in our systems or our applications, we can pull up a dashboard that we've saved in the past and really just have this like immediate idea of like what is happening, what is my system doing. And this all came from the fact that we imported one single library to export all of these metrics for us. Yeah, so I kind of want to go back over the histogram here. So I added this endpoint called /slow, which will sleep for a random amount of time, and then send a slow response. The reason behind this is like I want to fill up different buckets. So you can see like earlier I was like refreshing this, and then it said, okay, there were 5 requests that were 200 milliseconds or below. There were 18 requests that were 500 milliseconds or below. And that can be really useful because you can then start building graphs and obtaining information about a smaller amount of data. So like a histogram allows us to say, I want to know like what 95% of my requests were doing, right? This is like a slightly more useful query to understand where were my requests spending time, how much, like I don't really care about the last 5% because there's always going to be outliers. What were 95% of my requests doing? And the reason why we do this is just to save ourselves some sanity. It can just be really difficult to really care about where every request is going in our system, so we only care about the 95% best of them. But this is just another example of, we can see as our system is scaling up or getting down, and how much time we're spending doing things. And so you can sort of imagine a world where if you're like an on-call developer or you're an SRE or whatever, and you're like, this microservice is like behaving in a really weird way. What's going on? And then I can go and I can see like which routes are taking the most amount of time to complete. Yeah, so that's the power of Prometheus, right? So just by providing this like simple text kind of output, we can see that we can generate much more significant data and visualizations from this, right? And I can expand if I want to go out and look at the last 30 minutes or the last 12 hours, which I wasn't running this for 12 hours. I can start to see what's happening over a longer period of time in my application. So you can start comparing like what did my application or my software look like yesterday compared to today, which is just a really useful debugging tool because, again, inevitably things will break. Another good example to show is that like there are some like static metrics that sometimes people will expose with Prometheus. So like, for example, there's one that gets automatically presented called the Node.js version, which we can just extract the version out. So you can imagine that might be useful to display if you're like deploying new versions of software, just to have that information readily available on your dashboard if you're ever trying to solve things. So yeah, that's kind of some of the examples of like what you can do with Prometheus and how you can isolate data and visualize things. So yeah, moving on. We've covered Grafana, we've covered dashboards, we've covered that Prometheus PromQL is kind of the way that we import this data into Grafana to do something useful with it. So the question then is like, okay, that was really cool. We had this like silly little Node application like that we instrumented with Prometheus metrics, and we got some like somewhat useful data, right? And that is nice, right? And that is a really powerful thing to do, but that's only really half the equation of like what Prometheus metrics can be. Prometheus metrics exist for every technology that you can pretty much imagine. If it exists, there is somebody who went out of their way to write an exporter for it, meaning that this format of Prometheus metrics can exist for anything, anywhere, anytime, because they're kind of simple. They're kind of dumb as well. So like this is a really important topic in like, you know, when you get into like really large cloud computing environments and you're dealing with clusters and Kubernetes and cluster health, because you can install an exporter on whatever your application is and start knowing the health of all of these things. So, you know, that's really the power of Prometheus, is just to know like, okay, this microservice is behaving weird. I'm going to go look at Redis, or I'm going to go look at MySQL and see how things are looking there. And you can start to narrow down solutions to problems pretty quickly by having these metrics already available for you, right? Just through the one tool of Grafana. So just to kind of give another example of like what this means is like, we can look at metrics for anything. So I'm willing to do my laptop. I went out of my way to go find an example of this. So there is an actual exporter for macOS that will export metrics about the status of your MacBook. And that's what this incredibly long metrics list is. I don't even know what even half of these mean. But you know, you can see like where your MacBook is sending CPU, and you can imagine like this could be the same thing for a Docker container or a server that you're overseeing and taking care of, right? It could be useful to have all of these metrics for your system. And on top of that, because of the ubiquity of Prometheus and Grafana, somebody had already created a node exporter for MacBook that I just imported. So you can see, right, over the last 30 minutes, I now have information. I guess I'm I'm using a lot of memory right now. But I have a graph now of what my personal system is doing, right? That's getting exported to Prometheus. Prometheus is pulling it in, and then Grafana is displaying it however it sees fit. And you know, we can see all of this data, and we can compare over time and see that, you know, maybe CPU usage or memory usage is dropped. Maybe like I close an application. And you know, this is kind of a silly example, right? Because no one really wants to like watch their MacBook with Prometheus. It's kind of silly. But if somebody was like doing, you know, had 1,000 Docker containers, or they really want to narrow in on one and see what is this Docker container doing, how much memory is it using, right? All of these concepts apply the same. You can go and write queries using PromQL to figure this out, right? So just to give like another example of how this looks, is it's just the amount of bytes that are being used, right? And you know, we can export this here. Yeah, and then we can compare and contrast and do all kinds of wonderful things with that. So that's another really good example, I think, of just the power of Prometheus, just to really prove that literally anything that exists, it has an exporter for it, which can really come in clutch if you're working with a technology that you don't really understand. Like, I don't know, I've had like situations personally where I've been using like MongoDB, and I have no idea of what my MongoDB instance is doing. Like, how much memory is it using? Is it like writing to disk too much? Something of that nature. But I can go find an exporter for MongoDB, attach it to my Mongo instance, and I instantly have a general idea of what's happening in my Mongo instance. So another really important topic that Prometheus can do, and even Grafana has like built-in like UI to do this, because for some reason it does. But Prometheus has the ability to do alerting. And this is probably, I think, that one of the biggest reasons why DevOps teams, engineering teams use Prometheus as much as they do, is because when systems break, you know, you need your engineers who are on call to look at it immediately. When things go down, you know, you're going to be costing your company hundreds of thousands of dollars every minute. I've seen it. It happens. It's scary. You don't want to be in those on-call rooms. It's really, really bad. So what Prometheus can do is, as it's pulling in metrics, right, kind of how we've seen before, it will also run a list of queries that you can write using PromQL to do alerting. So you can say like, oh, CPU usage is so high, or I can't ping this node, or only one Docker container is running out of 100, right? Alert Manager, which is built into Prometheus, will send notifications out through like a pre-configured list, right? So you can do email, you can do Discord, you can use Slack, whatever, operational tool your organization uses. I have a personal Prometheus instance at home that will like let me know like whenever my own personal servers go down, which is like not particularly useful, but it's good to know like if something goes down, I can know about it and I can fix it the minute it happens. And that's probably the number one and most useful thing that Prometheus really offers, is just sort of that security and state of mind to know that if systems start breaking, we can let our operations teams, our on-call teams, our developers know about it. I don't have a great example for this because honestly, this got this got a little difficult with like setting up API tokens, and I didn't really feel like screwing with the Slack API to get this to work. But the general idea is that you can write queries and programmatically to alert different operational teams. So just to like quickly recap what we've covered so far. So Prometheus and Grafana are two separate ideas, but they are often heavily reliant on each other. They can be extremely powerful, both with like alerting teams or debugging systems and looking at what our systems are actually doing to figure out and isolate issues. The other thing I really want to bring home is that the idea that Prometheus metrics are very easy to add. Again, it was a few lines of code that gave us free Prometheus metrics on what our system is actually doing. I cannot describe sort of like the kind of empowering feeling of like just bringing in so I write Rust at work, and just bringing in one crate, and I don't know Rust very well, to just bring in a crate and just be like, oh, that's how much time we're spending on networking operations, or that's how much time we're writing to disk, right? That gives me a state of mind and like encouragement to know that like my system is not going to fail on me in the middle of the night, and I'm not going to know about it. I think just most importantly, just to recap, is that when as developers, we really do have this kind of responsibility to our organizations, our companies, that when we write code, that it's got to be solvable, it's got to be fixable, people are going to stand it. When code is written, we will write it once, but if you work for a company that's going to be around, it's going to be written it's going to be read hundreds of times. And so Prometheus is just one extra tool to kind of give us this sort of security that we are building reliable systems that really will scale and last for 5, 10, 20 years. So that's kind of the end of my presentation. Any questions? Fred.
So I noticed that you brought in a package and then you added a counter to your login route.
Sure.
For you. Is there a way to get metrics without having to add like actual code, and what are your functions?
So that is a really good question, because that's like probably one of the biggest complaints I would say that engineers have with Prometheus is like, wow, I really don't want to have to like litter counters and add additions to histograms and like think about what a bucket fills, and like that's just really obnoxious. I totally agree with you. So the answer is there's often middleware, which I didn't even cover because I don't really know Node very well. There is often middleware that does all of this for you. I was showing kind of metrics specifically for the Node runtime. I was researching it, but I didn't get that far. But this is like using an example written in Express, which is like a very popular Node web library that will do all of that sort of instrumentation automatically itself. Because I agree, like if I had to add specific logic for metrics everywhere, that would be really awful. And there's some cases that you can't really get around it, right? Like in this example, we're just trying to see like how many times the homepage has been like added to. But like if we were just trying to have a general idea of like how many requests are flowing through our systems, it would be really annoying. And so there are tons of examples and tons of libraries that will auto instrument all of this for you. Or you can implement all of this stuff in middlewares to kind of abstract that concept away as well. Because it is kind of annoying to like mix monitoring and business logic together. So that's it, yeah. Totally fair critique, but there are ways around it. Thank you. What's up?
We have a couple questions from chat. So the first one is, how can I use Prometheus to check if a routing number service has fallen over and needs to be written?
Gosh. Can I get the username on who read that?
Kill a gorilla AFB.
Kill a gorilla. Okay, I think I know who that is.
They did say, hey Ryan, how you been, homie? So they obviously.
I know who that is. That's Frankie. I'm like pretty sure that's Frankie. The answer to that is that your metrics stop appearing, and that's when you start alerting. Alert manager, like I'm going to answer that question like it's serious, but if you have a target or a service or something, and it stops producing metrics, that is a complete case where alert manager will immediately like start paging people or sending notifications, or however it's configured to do that. Because that does happen from time to time. Applications crash. They're unrecoverable. It does happen. So, thanks, Frankie. Appreciate that.
We got one more. I'm thinking of using Cosmos DB and wondering if you have any tips for monitoring it.
Tell me the name on that one.
The same person.
Cosmos DB is a wonderful application. I love it. Yeah. I'm being trolled actively during the presentation. Oh man, that's funny. Actually, I don't know. I guess there probably is Prometheus exporters for like. So I know like Google, at least at the minimum, has Prometheus exporters for like your like whatever their like cloud computing is for their database or whatever. So you can like you can create metrics to be like, how many times am I writing to my database? Because when in those cloud computing environments, it can cost a lot of money to like write into the database. And so I've seen actual dashboards that are created in Grafana, and all they are is just tracking how many times you're writing and then multiplying it by 10 cents so you can figure out how much money you're wasting every time you write to the database. That's like an actual thing I've seen done. I know I saw this when I was researching this. There was like this really wonderful dashboard, and people. I guess I should have said this: is that all dashboards and Prometheus metrics, like a lot of people sort of make it to where you can import it yourself. Like there's like an import button on the Grafana website to bring in dashboards like automatically, so you don't have to make them yourself because it can be kind of tedious. But like you can keep track of like how much your server bill costs at DigitalOcean, and people will have that as a dashboard, so they know how much money they're spending. So it doesn't have to be just systems data. It can be like if you're like an operation, or not an operation, but you're like a marketing person, and you want to know like how much time a user's spending on our website, or if you want to find out the amount of users that are active on your website, things like that. There's nothing stopping you from using Grafana. It's just that generally monitoring is kind of what it's used for. So, yeah. I'm getting trolled by Killer Gorilla in the chat.
I think you might have just answered this, but you mentioned that there's different ways to present the data with like already configured dashboards.
Yes.
Yeah.
So like a lot of these so I like kind of created all of these dashboards, but there's a kind of an infinite way to sort of like redisplay things. Like, I mean, this makes no sense, but if you want to bar chart a CPU usage at every minute, you could do that. And there's obviously like different types. You can think of this as like the Microsoft PowerPoint or Word of like data, right? This is, one of the powers of, I would say, Grafana. I mean, most people will kind of just use it for like its time series database because that's kind of the most useful thing, I would say. But there is all kinds of like query manipulations you can do to build dashboards to fit whatever your need. Like to kind of give like a better example, this like this memory usage thing here, it has to divide the amount to get megabytes, right? Divided by 1024. That's not what we were getting in Prometheus. We were getting just the amount of bytes we were using. But, we can manipulate our query real quick to just have like a better idea, more human readable format. So, yeah. Any further questions? Yeah, what's up?
So on Prometheus, do you run it locally per application, or do you run it like as a single node?
Ooh, that's a good question.
For all applications?
Yeah, that's a really good question. So Prometheus is like super scalable. There have been like companies that have run into issues like where Prometheus can't handle the amount of things to scrape. There are some companies, one that I previously worked for, I think they only use one instance of Prometheus on like a really beefy server, and it would just scrape in everything all at once. It's kind of like very dependent on your environment, your needs. I know like for my place of employment, we run one Prometheus instance like per data center, and we have like 400 data centers. So that's like one way you can break it up. Some people and some companies will have like one Prometheus specifically only for like Kubernetes, right? To pull in those metrics. So there's no exact right answer for it. How you deploy Prometheus is like pretty dependent on your circumstances. I would say like if you had Prometheus running on like a super easy $5 VM on DigitalOcean, like you could probably start scraping like 200 targets and with an equally large amount of metrics until you start running into issues. So it just sort of depends. And I should also mention this, like Grafana allows you to pull in multiple Prometheus instances. So you can add more Prometheus instances as you need to. And if you really want to get into it, there's like a whole thing called, there's this application called Thanos. Actually, I've been told it's not pronounced Thanos, but that sounds cooler. But Thanos is like a clustering solution for Prometheus. It allows you to basically hook up all your Prometheus instances, and you can execute one query on Thanos, and then it will like figure out how to execute all those queries on all those other instances of Prometheus. So it just is really highly dependent. Any further? Oh, what's up?
Do Prometheus or Grafana cost any money?
No, they are all free, all open source. So Prometheus is, I guess the steering community is the CNCF. It's kind of like Kubernetes. Like it's never going to cost anything. Grafana is also open source, also free to use. But I know they have their own like dumb cloud thing you can do. Like every other technology these days, you can buy the enterprise version. But no, they're free, open source. So. If you want good dashboards, by the way, I should mention this. The Home Lab subreddit, people just love making dashboards for like, what's the temperature outside? Or, I've seen dashboards for like, they import the pizza tracker, like at Domino's. And they export that to Prometheus metrics so you can like sort of watch on the graph when your pizza will be there. Yeah, so there's all kinds of silly things you can do. But the real power comes in just having the ability to just be like, what the hell is my system doing? All good?
I got one more.
Oh, let's hear it, yeah.
On that, specifically on your Node.js,
Yeah,
the incrementer,
yeah.
does it essentially work as kind of a callback, so it waits for the response to come back to the network and then fire off the request to Prometheus to?
So it's kind of like, I guess the way you could think about this is like this is just an in-memory value that Prometheus or that Node will hold on to, and the only time this ever gets accessed is whenever this /metrics gets called. So it's pull based. You're not like keeping some static connection open with Prometheus. It's just a sort of like kind of keeping track internally and then just reporting it when called upon. So this number is not adding any other overhead to your system or your code. It's just it would be the same of like creating a variable and then adding one to it. So you're not adding any like more memory really other than the 4 bytes or whatever. You're just keeping one number in memory and then spitting it out when requested. And that's another thing. Like there's very little performance penalty for this as well. That's another like really useful thing about Prometheus is that you're not like, unless your metric itself that you're trying to export is a performance penalty, the actual pulling of metrics is quite lightweight, so it doesn't really hurt you in the long run. Fred.
The metrics endpoint.
Yeah.
Is it all writing to a single file on the system?
It's not written anywhere. I mean, it's just HTTP. It's just created on the fly.
Oh, okay.
Yeah, it's not served anywhere. Like it's straight up over HTTP, like plain text. Like if I inspect the code here, or well, hold on, view page source. Where are you at? Why can't I view page source? Am I blind? Oh, there we go. But if I view page source, it's literally just the text, right? There's no protocol here that's like behind the scenes. Like it's literally spitting out on that endpoint, creating this on the fly. These are my metrics. And then Prometheus will pull these in. And there is something to be said. I didn't really get into this of like how Prometheus itself stores metrics. Obviously, it's using a time series database to store things. But how you do that can be kind of dependent on your architecture, on like how you're deploying it. Because like sometimes you could like save it to local disk and that's fine. But like what if you have like 5 Prometheus instances, maybe, and then like things shift around because you have like some cloud computing environment. You don't want to save things to disk then. So you can save things in like Elasticsearch, and there's all kinds of different ways that metrics can be stored and saved to be retrieved for later. But generally, at least these metrics endpoints, right? And I guess I could show this one too, you know, with my the one with my laptop. You know, it's just spitting out this like dumb text file that's, you know, being created on the fly. Yes.
Follow
Follow
up. So just so I understand, when you set up Prometheus, you're essentially installing an agent on your server,
Yes.
so to speak.
But it doesn't have to be on that server, but yes.
Well, how's it going to get the metrics from?
Well, like you could, I mean, it's over HTTP, so like there's no guarantee or requirement that Prometheus has to run on the same server that it's scraping metrics
No,
off.
I'm not asking about running it on the same server.
Oh, okay, yeah.
I'm curious, like imagine Prometheus is on server B.
Sure.
And you're trying to get metrics from server A and C. Right?
Yeah.
So you install an agent on A and C so B can fetch the data, right?
No, you don't have to install an agent. It's just over HTTP. So you can think of Prometheus itself because it's pull based, right? It's not like your application is pushing anything out. It's Prometheus is reaching out to you and saying, what can you offer me right now when it comes to metrics?
So you have to have an open port.
Yes.
Web server for it to.
Not, I mean, technically, yes, it's a web server, but it's still like plain text, like kind of, like if I go back, right, just to the architecture diagram. So like we have Prometheus that's, you know, scraping, pulling in data from things that have metrics.
I guess I'm still confused why there's still no agent, because like on your, say you're trying to pull metrics from a device, right? Like it has to somehow write to this thing that's serving the metrics for Prometheus to pull, right?
Yes, it would need to have like some sort of HTTP handler that's running on whatever port to pull from. That is 100% true. But that's as far as it goes, right? As long as you can expose an IP and a port and some data, then you're on that port, on the /metrics endpoint, it doesn't care. There's no further, I guess, implementation or agent required. It's really dumb. It's just HTTP. Yeah, what's up?
In that same vein of it being just HTTP, is there anything built in to protect these routes that serve up the metrics?
Yes, and that has been a security vulnerability that some organizations have run into. Yes, there is like basic auth, there is like JWTs, API tokens. Like there are things you can do to protect these endpoints because, like, I mean, you wouldn't want this exposed. Like you would not want to be serving internal metrics about your service to the world. That would be really bad. Because that has been a thing that has gotten a few companies before. But also at the same time, like hopefully if you are deploying microservices or, Postgres or like whatever you're monitoring, whatever is useful, it shouldn't be accessible from the outside world anyways. And just, internally things should be happening. So. Yeah.
I think we're good. Thank you
All
so
right.
much.
Thank
Ryan.
you, everybody.